Hello everyone, in this video we are looking to yet another container, but it is not a part of actual C++ container, rather it is part of the utility library that is known as pair. So this pair finds very good way to be combined with the other containers and solve many problems. So as the name suggests, pair, it just maps two elements, and these two elements are considered as a one unit. So the first unit can be of any data type. Similarly, the second unit can be of any data type. We'll be seeing next. So for this pair, we need to bring a utility library that is present in C++. Okay, as you have seen, utility library consists of pair. So let us see how we can declare a pair. So a pair is declared with a pair keyword. So in this brackets, we need to pass two data types. One is for first, one is for second. So let us pass integer and integer. So I want to store a pair that is of integer and integer type, or let us say integer or char type. So now let us insert a value in this pair. So we can do p dot first equal to 100. So this first is a keyword followed by a dot operator that gives access to this first element, that is integer value. So we have put in there 100. Let us insert to the second. So this second is a keyword again followed by the dot operator that gives access to this second element. So this is a char. So let us put a over there. So we have successfully put on the values to this pair. Let us look how to print that. In similar fashion, we have accessed that element and put on value. Same way we can access again and check. This is second, this is first. Okay, let us compile and test. Plus pair.cpp. Okay, it is successfully compiled. As you can see, it's showing a and 10. So a is basically second and 100 is basically first. Okay, let us look at some other functions of this pair. So there is a function known as make pair that will directly make this pair. You don't need to initialize this as separate. So we can directly do, let us comment this out. We can directly do p equal to make underscore pair. So this will make a pair. So inside it you need to pass on the values. Let us pass on 100 and a again. Save it, and again we can access it in the same similar fashion as we have done above. So let us copy and paste that. Okay, let us compile and check. Okay, as you can see, a and 100. So these are two different way that we can make pair, but this one is greatly used and easy also. So if you have seen my maps video, we have used pair there also. So a map element is basically a pair. So let us look at some other functions of pair as well. So let us look at the operators. So basically you can compare two pairs. So let us declare one more pair. So I have declared the pair of same type as of this p. So this will greatly help us to understand how the logical operators can be used with the pairs. So let us look at, let us first insert the values to this pair. Let us insert 100 and a. Yeah. So as you can see, these two pair are same. So you can directly compare p equal to p2. You can directly compare these two pairs. So let us compile and check. As you can see, it is returning same. So this value is compared with this value, yes, it's same. This value is compared to this value, yes, it is same. So let us write the else part as well. So let us change the first element of number 1 pair. As you can see, it is not same. So we can use certain logical operator like this equal to. We can also use less than equal to. We can also use greater than equal to. We can also use not equal to, and we can also use equal to assignment operator. So this will assign one pair to another. So you can check by assigning this logical operator to this if statement, how does it work. So it can compare the pair by element and returns the value. So these are great utilities for comparing two pairs. So these pairs are not used in much in the standalone fashion, rather they are combined with other containers library such as vectors, maps, sets, and provides a great way to solve problems.